Welcome to my channel. In this session, we will discuss the properties of angular bisectors in triangles. Then we'll apply these properties and answer a couple of questions. This is the 10th in the series of geometry videos that we are making. What is an angular bisector? If you look at this triangle ABC, this is angle A. If you draw a line that divides this into two equal parts, this line is called the angular bisector. And if I extend this line, it will meet the opposite side at some point. Let us say that point is D. So we can say that AD is the angular bisector of angle A, that is angle BAC. Right? Similarly, for angle B, this is angle B, if I draw a line which divides this angle into two equal parts, or if you draw this, take angle C, if you draw a line that divides the angle C into two equal parts, they all will meet at a point. That point is called incenter. But anyhow, regarding incenter, we will discuss in detail in one of the following sessions. But we'll concentrate on what is the properties of angular bisector here. So what is an angular bisector? An angular bisector is a line that divides the angle into two equal parts. Right. Now, this angular bisector, as I said, when you are extending it, it is cutting the opposite side at D means, how this D divides this BC means, that an angular bisector divides the opposite side in the ratio of adjacent sides. It means DB is to DC. This portion DB is to DC will be same as AB is to AC. That's what DB, BD or DB, both are same. BD by DC is same as AB by AC. An angular bisector divides the opposite side in the ratio of adjacent sides. Let's consider one more. Suppose from B, if I extend this cuts this at, say, let us say E. Now this B is cutting this, BE will divide this AC in what ratio means, you can say this EC by EA will be same as BC by BA. Right? So this is the important property of an angular bisector. And here, this is the internal angular bisector. That's why this is dividing, this AD is dividing BC internally as BD and DC. It is dividing them internally. And the same property is applied to even external angular bisector. Only thing is it divides externally there. Let's take up a diagram. If you consider this diagram in this triangle ABC, if I extend this line, this is the external angle at A. This is the external angle at A. If you draw this AD, which is the external angle, external angular bisector. So AD is the external angular bisector. This is the external angular bisector. In the previous case, this was, as we discussed, this is the internal angular bisector, right? Okay. So now, this external angular bisector AD and this CB, if you join that, now this AD will divide BC in the ratio of AB is to AC only. What is the statement I said? An angular bisector divides the opposite side in the ratio of adjacent sides. If it is internal angular bisector, it divides internally. If it is external angular bisector, it divides externally. It means DB by DC will be same as AB by AC. I repeat, DB by DC will be same as AB by AC. Only thing is it is dividing externally. Right? So these 2 points are very important points on angular bisector. What is an angular bisector? The line that divides the angle into two equal parts. It can be internal angular bisector, it can be external angular bisector. Now, let's solve a couple of questions based on this. In a triangle ABC, AD is the angular bisector of angle BAC. AB is 12 centimeters, BD is 8 centimeters, and DC is 10 centimeters. Find AC. Let me draw. In a triangle ABC, AD is the angular bisector of angle BAC. BAC is this. This is the angular bisector, means this divides this into two equal portions. it touches at D. Now we know an angular bisector divides opposite side in the ratio adjacent sides means dB by DC will be same as AB by AC. Let's substitute the numbers we have here. We know BD or DB is 8. We know DC is 10. This is 8, this is 10. And we know AB is 12. And we have to find what is this. Okay. AB is 12. AC we have to find out. Right. We can see here. 4 2s, 4 3s, 2 5s. If I cross multiply, AC equals to 3 5s 15. This is 15. Simple question. Done. So let's take up one more. In a triangle ABC, the external angular bisector of angle A meets CB produced at D. If AB is 12 centimeters, BC is 16 centimeters, and AC is 25 centimeters, find BD. Now, if you take triangle ABC diagram, AB is 12, BC is 16, and AC is 25. The external angular bisector of angle A, let me just extend this. This is the external angle at A. This external angular bisector, this meets the CB produced, that is extended at D. Now what this AD will be? The external angular bisector. As we discussed, whether it's internal angular bisector or external angular bisector, it divides this opposite side in the ratio of adjacent sides. That means DB by DC will be equal to AB by AC. Now we know BD we don't know, let it be X. So DB means I can write X by DC. DC means this entire side, X plus 16 is equal to AB. What is AB? 12 by AC, that is 25. If I cross multiply, 25x equals to 12x plus 192. If it comes this side, 13x equals to 192, or x equals to 192 by 13. 13 1s 13, 62, 13 4s 52, 14 10 by 13 centimeters. So this is, we want BD, that BD is 14 10 by 13 centimeters. Right? So these are a couple of interesting points on angular bisectors. Students, for more on geometry, please reach my profile at Udemy. The link is given below in the description. You will find a comprehensive course on geometry. Thank you.